Namaste, this is Mallikarjuna, working as an assistant professor in Department of Mechanical Engineering, MIT, Mysore. Today we are in the Fluid Mechanics Laboratory. In this session, we will be conducting an experiment on centrifugal pump. Before moving on to the experimental part, let us try to understand what is pump. Pump is a mechanical device which is used to energize the fluid or which is used to discharge the fluid. Usually, pump requires an mechanical energy, so that mechanical energy will be converted into fluid energy or it can be converted into a head. So that is what is the function of pump. Based on the action of pump, the pumps are classified into two categories. One is reciprocating action, another one is rotary action. Based on the reciprocating action, pumps are classified into reciprocating pumps. Based on the rotary action, pumps are classified into rotary pumps. Here we have centrifugal pump. Centrifugal pump is an example for rotary pump because centrifugal action is created because of rotation of the impeller of the pump. Try to understand this meaning first. Centrifugal, in the sense, centrifugal is nothing but the action which throws away the object from the center. That means object will be thrown away from the center. If such a thing is happening in a device, then the device is based on centrifugal force. If the pump is acting based on that action, then I will call it as a centrifugal pump. In this session, we will be conducting experiment on one such pump, which is nothing but centrifugal pump. If we look onto the applications of centrifugal pump, in our day-by-day domestic life, we used to lift the water from sump to the overhead tank. In such situation, we have adopted centrifugal pump. In many of the situations, we need to supply the water to the various cities. In that channels also, water is pressurized or water is discharged with the help of centrifugal pumps only. So this is what is the application of centrifugal pump. We will study centrifugal pump detailedly in our theory subject fluid mechanics, which comes in 4th semester. So this is what is the importance of centrifugal pump. Now let us move towards the experimental part. The aim of the experiment is to conduct the performance test for the given centrifugal pump and to plot the characteristic curves. And operators that we are going to use to conduct the performance test are test rate of centrifugal pump and stopwatch. So this is the aim and this is the operators. Let us look on to the various observations that we need to do while conducting the experiment. Area of the measuring tank, which is denoted by A, the value is 0.11 meter square. This measuring tank is used to measure the actual discharge. Energy meter constant, which is denoted by K, 1600 impeller rotations per kilowatt hour. Energy meter is required in order to measure the amount of electrical energy supplied to the centrifugal pump. Number of energy meter rotations, N. What is the energy meter disk rotation, which is denoted by N, and it is 10 times, 10 rotations. Rise in the water level of collecting tank. This is the collecting tank or measuring tank we have. Rise in the water level of that tank will be fixed. It is fixed by us only 10 centimeters or 0.1 meters. Efficiency of the motor. Why the motor is actually required? We need to supply the energy to the centrifugal pump. In order to supply the energy to the centrifugal pump, we need the motor. So that motor has an efficiency of 75%, in the sense 0.75. This 75% is indicating that the energy supplied by the motor is 75% to that of the pump. So these are the few observations that we need to do before conducting the centrifugal pump experiment. Go. Okay, now here we are with the experimental setup of centrifugal pump. Let us look on to the various components that are present in the experimental test tray. Okay, this is the centrifugal pump on which we are conducting the experiment. This centrifugal pump has to be energized with the help of the electrical motor. So this is the electrical motor which is going to supply the energy to the centrifugal pump through belt drive. So this is the belt drive through which the energy is supplied to the centrifugal pump. Here we are provided with one sensor. This is going to record the rotation of this particular field, and here we have one bolt. This is actually acting as a mark. How much rotations this is going to done per minute will be sensed by this sensor, and this will be noted in the control panel. So now if we look onto the various other pipelines what we have here, so this one is the suction pipeline from the sump. So this pipeline is going to suck the water from the sump. Then this water sucked will be energized and will be pumped through the delivery pipeline. So this is the delivery pipeline we have. In order to adjust the delivery, we need to operate this valve. So this is completely closed position now. In order to control the flow rate, we can open this so that we can control the delivery from the pump. And then here one small opening is given. This opening is provided in order to avoid the priming. That is, if I have to start the device now, then I need to make sure that throughout this suction pipeline the water is filled, or else if I start without filling the water, the air may rush into the pipeline. That may cause the priming problems. So because of that, initially we need to make sure this pipeline is filled with water, and this valve needs to be closed before conducting the experiment. Now let us look onto this. This is the collecting tank which is actually used in order to measure the actual discharge. On the other side, we have a scale over here. With the help of the scale, we need to look onto the actual discharge that is happening through the centrifugal pump. So this is what is the scale which is provided on the collecting tank. Now let us look onto the components which are present on the control panel. So this is the electrical switch which is used to switch on the device, and this is the main on and off button. So in order to switch on the system, we need to switch this on. And here we have two gauges. One is the suction pressure gauge, another one is the delivery pressure gauge. If you look onto the pipelines over here, two of the pipelines are connected to the panel. So this is actually the delivery side pipeline. So this pipeline is connected to the delivery gauge, and this is the suction pipeline, and this is connected to the suction pressure gauge. Thereby we will be measuring suction pressure as well as the delivery pressure. Next, this is the energy meter. So this energy meter is going to give us the energy that is supplied from the motor to the pump, and we have to measure the speed with which the belt drive is running. That has to be noted down here. This is censored by the sensor which we have provided at the centrifugal pump side. So this is what is the various components that are present in the centrifugal pump test rig. So now if you want to conduct the experiment, we need to make sure that initially the initial pipeline is filled, suction pipeline is filled with the water. Then we need to switch on the mains from either side. So now I am conducting the experiment. Before that, I need to close this valve. Now this pipeline is filled with the water, and I am closing this valve. Okay, now the water is present in the suction pipeline. Now I am switching on the mains. So here it is in the off position. Please turn this on, and then look onto the reading of the belt drive. It is initially 0 because motor is not at all running. So now this is the green button which we have to press in order to start the machine. So I am pressing it now. Now the motor is supplying the energy. Motor is supplying the energy to the pump line. So now with the help of the delivery valve what we are provided with, please adjust the delivery pressure over here. So now the delivery pressure is a 0.5. This has to be adjusted with the help of the delivery valve. So now I am adjusting this. Now it is 0.55. Now it is 0.6 kg per centimeter square. So this is what is the delivery pressure that I have set. For this delivery pressure, this is the speed with which the motor is supplying the energy to the pump line. So now this is the suction pressure that has been created for this delivery what we have set it up. Please note down this value also. Outer reading we need to take down. This is in between 0 to 100. So almost the value is 50 mm of Hg for 0.6 kg centimeter square delivery pressure. So now we are aware of speed with which the motor is supplying the energy to the pump, delivery pressure as well as the suction pressure. Okay, now to measure the energy supplied by the motor to the pump, we need to look onto this device. One of the blink is blinking over here. For a fixed amount of time, how many number of times this blink is going to happen, that needs to be recorded. Let us go through the stopwatch now. So I have started the stopwatch. For a minute, how many blinks we are going to take, or else for a fixed number of blinks, what is the amount of time taken. In both the way, you can measure the energy supplied by the motor. So now this reading has been taken. So now we are aware of the energy supplied by the motor to the pump. Again, on the other side, we have a collecting tank. This collecting tank is used in order to measure the actual discharge that is happening from the pump. So this is the delivery pipeline. This is supplying the water to the collecting tank. On the collecting tank, we have mounted the scale. So this scale is going to show us the reading. So what we have to do is we need to close this valve. For a fixed rise, what is the amount of time taken? So now, for a 10 centimeter rise, I have noted down the time taken for a 10 centimeter rise. So this is how I can calculate the actual discharge that is happening to the pump. So this is what is related to the one after trial. Now if I have to repeat the trial, I need to adjust the delivery pressure from 0.6 to 0.7. Please open the valve, clear data now. So now the pressure is 0.7 kg per centimeter square. I am conducting the second trial for a 0.7 kg per centimeter square. Now this is the speed with which the belt is running, and this is the suction pressure. And again, I need to look onto the energy supplied by the motor to the pump, as well as for this delivery, what is the amount of delivery pressure, what is the amount of actual discharge that is happening. So this ends the second trial. In the same way, I can repeat the number of trials, and then I can go for the tabulation as well as calculation. Now, let us look on to the tabulated values from the experiment. Trial number 1, speed in terms of RPM has been noted down over here, 1815 RPM. Delivery head, that means the head with which the water is getting delivered is 0.6 kg per centimeter square. This has been converted into meters of water. The value has become 6. Suction head, what is the head with which the water is sucked from the tank? That head is, in terms of meters of mercury, is 0.06. If I convert this into meters of water, that becomes 0.816. Total head, now total head will be suction head plus delivery head. Suction head plus delivery head will become the total head. If I add this and this will become 6.816. Now we need to measure the actual discharge with the help of the collecting tank. In the collecting tank, water is continuously getting collected. For the fixed amount of time, what is the amount of water which is collected in the collecting tank is measured, and that time taken is nothing but 0.13 seconds. We have already fixed the height in the collecting tank, which is nothing but 10 centimeters. For 10 centimeters of water collection, time taken is 5.13 seconds. Actual discharge, this will be measured with the help of the formula. So that has come around 2.14 into 10 to the power of -3. Time of energy meter rotations, we have fixed it as 10 blinks. So for 10 blinks, this is the amount of time taken by the energy meter. This energy input by the motor to the pump, because pump is a device which converts mechanical energy into fluid energy. So pump requires or motor supplies this much amount of electrical input to the pump. Next thing is output from the pump. What is the energy with which the water is lifted or water is discharged? That amount of energy is this much. And the efficiency of the pump, which is nothing but the output divided by input, that is going to be this much. All these values will be calculated over there. Let us look on to the calculation now so that we will get the clarification about the values what we have got now. So I have done the calculation for the trial number 1. Trial number 1 is this one. First calculation is suction head. What is the head of suction for the pump? That is capital HS, which is nothing but small h's into 13,600 divided by 1000. This is the converted formula. So now small h's, this is the suction head, 0.06 in terms of meters of mercury. This has to be converted into meters of water. So the formula to convert the small h's into capital H's, that means head it is in terms of mercury into head in terms of water, is this. Upon substitution we have got the suction head as 0.816 meters. That is what is this suction head in terms of meters of water. Second calculation is delivery head, which is denoted by capital H suffix D, which is equal to small hd into 10. This is the conversion for the delivery head, because this delivery head is in terms of kg per centimeter square. This has to be converted into meters of water. So this is in terms of kg per centimeter square. If I have to convert this into meters of water, this has to be multiplied by 10. So 0.6 is multiplied by 10, which will be around 6. So that is what is the delivery head, 6 meters. Now if I need overall head, that is nothing but total head. This is nothing but delivery head plus this suction head. That means 6 plus 0.816 will be around 6.816 meters. So that is what is overall head. And next thing is actual discharge. We have made use of collecting tank to look on to the actual discharge. Actual discharge is given by collecting tank area multiplied by the height of the collection of water divided by time taken for this collection of water. A into x divided by T. From the observation, we know area of the collecting tank is 0.11 into height for which the water is collected is 0.1 divided by time taken for that. We have measured that over here, which is nothing but 5.13. From that calculation, we have got the actual discharge as this much meter cube per second. Next thing is input energy that is provided by the motor to the pump is given by N into 3600 divided by K times of time. This N is the energy meter rotation. This is the constant multiplied. K is the energy meter constant. Time taken for number of rotations or number of blinks of energy meter. This is nothing but the motor efficiency, because motor is going to supply the energy to the pump. That is why we have multiplied the motor efficiency to this formula. Upon substitution of the values, we have got input energy that is supplied to the device. I mean centrifugal pump is 0.075 kilowatts. This is the amount of energy supplied to the device. I mean centrifugal pump. Let us move on to the output now. Output from the centrifugal pump, which is nothing but small w q actual head with which the water is getting lifted. This is the total head. I mean suction head plus delivery head. This is nothing but total head. So now W is nothing but rho into G. Rho is nothing but the density of the water and G is nothing but the gravitational pull. Density of water is 1000 and gravitational pull is 9.81. Multiplication of those two will get us the value of 9810. Q actual we have measured in the previous step. I have substituted back over here, and head, total head is nothing but summation of suction as well as the delivery head. That is what is this divided by 1000 will give us the value of 0.143 kilowatts. Now this is the power that is available at the discharged water, I mean lifted water, and this is the energy which is supplied to the pump. If you want the efficiency of the pump, efficiency is nothing but the output from the pump to the input to the pump. So output is nothing but this much, 0.1430. Input to the pump from the motor is this much. So if I solve these two, I will get 0.202 R, which is nothing but 20.2% is the efficiency of the centrifugal pump. So this is what is the calculation for trial number 1. That is what we have made in the form of tabular column. Now if I repeat the experiment for the next trial, so these are the values for the next trial. So we have done 2 trials over here and we have all the calculation for both the trials. So this is what is regarding the tabular column as well as the calculation. And in the end we have performance test as well as plotting the characteristic curves. Characteristic curves are those which are going to predict how the device is going to behave upon various variables. So we have a standard relation for the pumps over here. This is the total head. Total head is always inversely proportional to the discharge, and total head is directly proportional to the efficiency. This is what is the relation which needs to be followed by the pump, or pump is going to follow this relation. Now let us look on to the tabulated values, whether they are following the standard relations or not. First characteristic curve is head versus Q actual. This is the total head divided versus actual discharge from the pump. If we look on to the standard curve, H, higher the value of H, lower the value of Q actual. Higher the value of Q actual, lower the value of H. That means H is inversely proportional to discharge. That is what is the relation, standard relation. This has to be observed in our tabulated values. H versus Q actual. Look on to the H. Here this is the total head and this is the actual discharge. Lower the value of H, higher the value of actual discharge. Lower the value of H, higher the value of actual discharge. Higher the value of H, lower the value of actual discharge. Please compare these two values so that we can observe the same relation. The H is inversely proportional to the actual discharge. Whatever the standard relation is there, standard curve is there, our experiment is also following the same trend. One more characteristic curve is efficiency and head. This is clearly saying that lower the value of H, lower will be the efficiency. Higher the value of H, higher will be the efficiency. That means H is directly proportional to efficiency. H is directly proportional to efficiency. That has to be seen in our tabulated values. This is the H. H is 6.816 and 7.68. So by these two values I can say this is the lower head and efficiency is over here 0.202. For 6.816 head efficiency is 0.202. For 7.68 head efficiency is 0.220. Lower value, lower value, higher value, higher value. That means head is directly proportional to the efficiency. Here also head is directly proportional to the efficiency. That means whatever the standard relation is there, our tabulated values are also following the same trend. So this is what was our aim actually, to conduct the performance test. Performance test has been conducted and values are tabulated as well as calculated. Along with that, we have plotted the characteristic curves which are also following the same trend what we have got in the theoretical aspect. So this is what is related to the centrifugal pump experiment. Apart from this, we have a few important Viva questions for this experiment. Let us look on to the Viva questions one by one. Very first question is,
differentiate between pumps and turbines.
Okay, differentiate between pumps and turbines. We know pump is a device which has to be run based on the supply of electrical energy. That means pump is going to convert the electrical energy into the fluid energy. Mechanical energy, I can say, electrical energy can be converted into mechanical. That mechanical energy has to be converted into fluid energy. That is the pump's work. Whereas turbine's job is to convert the fluid energy into mechanical, thereby electrical. Almost both are reverse to each other. For the pump, it is electrical energy, mechanical energy, then fluid energy. Whereas for the turbine, fluid energy to mechanical energy to electrical energy. So this is what is the first difference, and we can say pump is a power absorbing device, whereas turbine is a power generating device to us. So these two are the main differences between pumps as well as the turbine.
Which type of pump is used usually for domestic purpose?
Okay, we are very aware in domestic purpose we are using the centrifugal kind of pumps because rotary action is the one which is more efficient when compared to that of reciprocating action. In almost all domestic applications we are using centrifugal pumps. Next question is,
What is cavitation and what are its causes and effects? Also explain how cavitation can be avoided.
yeah, the question is regarding the cavitation and its effect and how to avoid the cavitation. Cavitation is the process of bursting of the bubbles which are formed in the passage of the centrifugal pump. What is the reason for the formation of the bubbles? Let us look on this. Whenever the pressure inside the device gets reduced to vapor pressure or less than the vapor pressure, during that time boiling of the liquid starts at the constant pressure. You need to keep this in mind. Temperature is not varying. The pressure of the fluid comes down below that of the vapor pressure at the constant temperature. During that time bubbles are going to form because of the boiling of fluid. This bubble formation is called as the cavitation because these bubbles are going to burst whenever it touches the rotary aspects or rotary devices of the pump. When this bubbles are going to burst on the equipments, these bubbles have effect of eroding the material. This is what is the one of the problem. Material can be eroded. This can generate huge noise. This can set up various vibrations in the device. So these are the main problems which are associated with the cavitation: noise, erosion of the blade or erosion of the material, as well as the vibration. How to avoid this cavitation? We need to be very careful while operating the pump. Very first thing is we need to make sure that water level should be very high in the suction side. There should not be any disturbance for the water level in the suction side. Next thing is temperature should be very optimum or very low. We should not rise the temperature. Next thing is the diameter of the impeller, which is also called as the eye of the pump. It is nothing but the rotary component of the pump should have higher diameter so that we can have huge amount of water collection at the inner side itself. That is the next aspect. If you want to avoid the cavitation, we can run one or more pumps parallel so that we can avoid the formation of the bubbles. Thereby we can avoid the cavitation. So cavitation is nothing but bursting of the bubbles at the various components of the pump because of decrease in pressure than that of the vapor pressure. The causes or effects are it is going to erode the material, it is going to generate huge noise, and it is going to create the vibration. If you want to avoid it, we have to look for huge diameter of the eye, I mean impeller. We can run the pumps parallelly and we can look for level of water in the suction side, which has to be very high. So these are all the avoiding procedure of that of cavitation. So these are the few Viva questions related to the experiment. So in this session, this much. Namaste.